Sweet. So we're going to talk about operating systems a little bit and system software. And we've been learning about computers, and I'm not going to rehash the entire thing. Hopefully you've got it by now. But one of the ways we categorize computers is computers can be broken down into hardware and software. Hardware can be broken down into IPOS, which are also the four basic functions of a computer. And IPOS, input device, output device, processing device, storage device, right? And software could be broken down into system software or application software. So last week we kind of looked at application software and saw some of the different things we could do with computers, what different applications we could run. Learned some of their names: word processing, spreadsheet, databases, financial management, like QuickBooks, really cool stuff. And this week we're going to look at system software. So if you had a diagram, if I was going to draw it on the board, you would have computers, and then computers would be well, I've got it right here, because you're like, Todd, I like pictures. Please show me pictures. I really work well with pictures. So above this would be computers, and computers would be broken down into hardware and software. And then software could be broken down into system software and application software. And system software could be broken down into your operating system, your utilities, and your drivers. So today we'll learn a little bit about operating systems, utilities, and drivers. How many people already know something about that? All right, cool. So we also saw this diagram. See, I just can't help it but to go back to my slides because they have the pictures I like. We also saw this on the board, right? There's the hardware, and then the operating system's on top of the hardware, and then application software runs on top of the operating system. That's a really instructive picture. Like when you think about how computers work, this is like one of the really important pictures right here. And it's important because the two components, hardware and software, are kissing each other right there. That's where they connect. And then software, operating system and application software, is broken down into two categories, and it shows the relationship between those two pieces of software. So those are like three really important pieces right there. Do you all understand this picture? Why this is important? How many people are kind of like, I don't quite see why it's important? Okay.
Because hardware is the foundation. Without hardware, nothing else works.
Yeah, and without software, the hardware is useless. You need them both. But it's a division of labor. And so the operating system's responsible for making the hardware operate. It's in the definition of the phrase, right? Operating system makes the hardware operate, makes your system operate. It's the operating system. And so the operating system knows how to run all the hardware, managing memory, getting things off the hard drive, accessing things in RAM, doing processes, calculations, printing something and driving those printers, making them work. The application software, and I already said this, I know, but the application software doesn't have to know how to work with all the printers in the world. All the application software has to do is give the print job to the operating system, and then the operating system goes and prints it. Do you see that? And then and then there's unique hardware that's out there. So we talked about this a little last week too. There's like a Motorola CPU, there's an AMD CPU, there's, Intel makes CPUs. And those different CPUs, there's different types. And they have different instruction sets. So AMD and Intel both write for like the x64 CPU. x64 or x86. So let's look at that. x64 or x86. How do you tell if it's 32-bit x86 or 64-bit x64? Right? There will be lists of entry, blah, blah, whatever. And what is x86 versus x64? So then people talk about that. But we could then kind of Wikipedia that. So we could go wiki x86. And x86 wiki is a family of backward compatible instruction set architectures based on the Intel 8086 CPU and its Intel 8088 variant, blah, 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 blah. So it's a specific piece of hardware. Specific piece of hardware. And software has to be written for that specific piece of hardware. And if that's like the 32-bit version, and then we had x64 wiki, and this is the 64-bit, so 8664. Also known as x64 is a 64-bit version of the x86 instruction set. So this is like the architecture of the CPU. It's like the language the CPU speaks, right? So when you write an operating system for that CPU, when you write software to interact with that CPU, you've got to use its instruction set because that hardware is built in a certain way, right? It has certain instruction sets. So this picture here, the operating system is written for the hardware, for specific hardware. Kind of just an interesting anecdote. Like sometimes when you look at software, like let's look at golang.org, which is the best programming language ever created. And if we go to download, right, here's AMD 64, AMD 64, AMD 64. How many people have seen like options before, right? Here's x86 64. Whoa, look at that, right? It's telling you which architecture, the CPU instruction set, which this is Windows x86, Mac's x86. So those are written, Mac OS now runs on x86, right? Or here's some different hardware, Linux ARM v8, PPC 64 LE. See architecture, that's the architecture. How many people have ever seen, like, I don't know where I could go and look at software downloads? Where? I don't know where I could go and look at software downloads. Like, where do you download software today for something? Chrome? Chrome download? Let's see if Google Chrome. Chrome download Chrome, and download Chrome. There's no choice there. But sometimes you have the choice. Do you want the 32-bit version or the 64-bit version?
Some websites go on your computer and then they check what you have.
Yeah, they'll check.
They'll
give you the right one. Has anybody ever seen that? Do you want 32-bit or 64? Anybody ever seen that? Have you been confused by it? Anybody ever been confused by it? Y'all know what it is. How would I find out if my Mac is 64-bit or 32-bit?
Check on your on your info on your Mac. You just go up to the top left, and it'll show you.
So about this Mac?
Yeah.
All right, where does it tell me if it's 32-bit or 64-bit?
You go to, I think, support. Right?
Support.
It should be one of
Storage. Displays.
Oh, you can search it up online.
Yeah, so what I've always had to do with the Mac is copy the processor, 2.5 gigahertz, drop that in, and say 32 or 64. How do I know if my Mac is 32-bit or 64-bit? Top left corner, open this Mac, click More Info, and so top, open About this Mac, click on More Info. About this Mac, more info. I don't have a more info. All right, click on more info. I have an overview, displays, system report, software update, service, support, storage, displays, support, more info, Mac help. But in Core i7 is 64-bit. There, that's a quick one. So that means I could run 64-bit software. Some software is written for 32-bit. Like if I open up Excel, you guys are like, wow, this tangent, I just do not care about this tangent. And if I open up a blank workbook, there we go, and Excel, about Excel, and does it tell me here? Doesn't tell me. Windows it tells me if it's 32-bit or 64-bit. Oh well. All right, cool. So the operating system manages the hardware, allows application software to work with the CPU, and manages, schedules, and coordinates tasks. And that's pretty much this picture right here. It gives a user interface. So back in the day, this was the user interface. This is how users interface with computers. What information do I have in this directory? Oh, let's go into documents. All right, they did command line interface back in the day. Now we have a graphical user interface, a bunch of graphics. Then utility programs, those perform general housekeeping tasks. So right here, right, it's the operating system. System software is broken up into the operating system and utilities. And it allows multitasking. So here are some operating systems. Windows, Mac OS, iOS for iPhones, Android for Google, Linux, open source. So the super cool thing about operating systems is like, and I said this already too, but just to make sure you hear the message, I could put whatever operating system I want on my hardware. So right now on this Mac, if I didn't like Microsoft or Apple anymore, I could just go to Ubuntu and download Linux and install Linux on my Mac on this hardware. And I'd have a different operating system on here. Ubuntu, downloads, desktop, download. Cool. Either DVD or USB port for the installer media to install it. And then they give you instructions. So those are some of the types of operating systems out there. This picture is pretty nice, I think. Operating system's kind of like a conductor. Manages the processor, manages memory and storage, provides a user interface, manages computer hardwares and peripherals, provides consistent interaction between applications and the CPU. So here we have command line interface, graphical user interface. A little bit about how it does hardware coordination. So let's say the CPU is playing a movie. And then there's an interrupt request from a printer. Hey, print this. So a memo about the movie is stored in RAM on the stack. And then the printing executes. And then the memo about the movie is brought back from RAM and says, hey, you know, here's the next piece of data for the movie. And then the movie continues playing. All super fast. Yeah, it's an exciting lecture. And so operating system also does memory and storage management. So RAM has limited capacity. And so sometimes if you run out of RAM, it'll store things on your hard disk drive or your solid disk drive. And so that's like called virtual memory because it's not real. It's just using your hard drive as if it's actually RAM. So it's called virtual memory. And it stores that in a swap file. And the process of storing it there is called paging. And if you do it too much, it's called thrashing.
What is it called, thrashing?
I don't know, because it makes your hard drive go. Because you hear the hard drive working, maybe. We already learned about what device drivers are. What's a device driver?
Like a USB?
No.
Isn't that like the hard drive?
So if I bought a printer at a yard sale, we didn't do this in here. HP, LaserJet, P1005. That sounds good. So here's my printer I bought at a yard sale. The guy I bought it from was selling it for $5 because he didn't have the software and it no longer worked with his computer. I thought $5, I'll give that a try. Bought it for $5, took it home, and I just came in here to HP LaserJet, software and drivers, go directly to software and driver results, go. And HP LaserJet P1005, detected operating system Mac OS X, driver product installation software, install Mac printer driver using Apple software update. Learn more. Okay, just do Apple software update, and the driver will automatically be there. And then my computer will know how to drive that printer and make it work. I just made that story up, by the way. That didn't really happen. But if you did find a printer at a yard sale, that's how you could do it. So that's what a driver is. So recently I was working with OBS, which is this software right here. That's like going into multiple infinities right there. Right? And OBS wasn't working on my friend's machine. And so we went into, on Windows, went in and updated his drivers, his video driver, and just a few of his other drivers, and then it worked. But the drivers needed to be updated. And so, you could Google that, update Windows drivers, and then find instructions like how do I update my drivers on Windows if something's not working. But that was the solution for my friend to update the drivers. So that's what drivers are. Plug and play is, and so here's a picture of Windows drivers, right? And you could say, hey, I want to update this network adapter driver, update it, and it'll go find if there's a new one and update it. How many already knew that? You know that already? Cool. Plug and play means, hey, you should be able to plug hardware in and it just works. An API. Anybody ever heard of API? So application programming interface. So when you have some sort of a system, you could provide an API to people. And that API allows other programmers to connect to that system. So the API might be for a service on the web. Like I want to be able to connect, like YouTube has APIs. Twitter has APIs, right? And I could go Google those and I could say Twitter API. There it is. And then I could look at like how can I connect and use Twitter stuff. And I could build applications.
Bless you.
I could build applications to do things, to kind of make Twitter, my software could do Twitter stuff. So one application is like Buffer app. Buffer app. I thought it was Buffer app. Buffer, that's it. And this this connects to like all the social media websites and connects, via their APIs. And so with Buffer, I could then manage all my social media in one piece of software. And when I want to post something, I could send it out to Facebook, Instagram, Twitter. I don't know what else is out there.
Facebook.
I already said Facebook.
Instagram.
I already said Instagram. Snapchat, whatever. I could send it out to all of them at once. And then when replies came in, I could see them all in one area and respond right here. So I don't have to go to all the different websites. And that'll make me more popular. And if I'm more popular and have more friends, my chances of doing better in life increase. I have a larger social following, huh?
Good logic.
The larger your social following, the larger your bank account. There's a correlation. So an API, also there's like APIs for operating systems. Like how do you interact with this operating system? And you could program against APIs if you're writing software for an operating system. So how does your computer start up? Step one, BIOS, right? We already talked about this. BIOS gives the basic input-output system and manages the exchange of data between the OS and the input-output devices. So that, right? Gets all the input output up and running so that you can start to load the operating system off of the hard drive into RAM. So RAM and the hard drive are able to communicate, and data can flow between them. It loads the OS into RAM. There we go. Ensures that essential peripheral devices are attached and operational. So BIOS also does that. Hey, do I have a keyboard? Do I have a mouse? Do I have a monitor? All right, and it'll give you beep codes. These old computers did if something was missing. And then booting the process, system files are loaded into RAM. The kernel, the essential component of the operating system, is loaded into RAM, and then configurations and customizations are loaded. So just a little bit about Windows. That is your desktop, right? The desktop is like the main area where everything's stored. So here's my, let's see, there's my, I don't know what that's called. Ooh, I'm going to get rid of desktop number 2. Can I do that? Bye. I don't need that. I don't know how to, would anybody know what the command is on a Mac with your hand to show your desktop? It's swipe. 3 fingers? 2 fingers? I don't know. But my desktop. All right, here's my desktop. If I look at it in Finder, or if I look at it here, I got to move all this out of the way. I've got a lot of stuff open. That's my desktop back there, right? You all know that. Just making sure. Taskbar. So here's another picture of desktop. Taskbar is this down here. This bar down at the bottom. Start menu is that little Windows icon right there. You have your search bar. You can pin things to your start menu. Right click it, choose pin, or pin it to your taskbar in Windows. Virtual desktops, you can create additional desktops so you could have different things open. That's kind of a cool thing to do. So operating systems also provide file management. Drives, libraries, folders, subfolders, files, like all that stuff is available here in Windows Explorer or in Finder on the Mac. The root directory is the top of the file structure. So my root in Mac is right there. Print working directory /. I'm at the root of this Mac. That's like the beginning of the directory structure. If I look to see what's in there, that's what's in there. It's kind of interesting. If I just go to my user directory, right, I'm in /users /Todd McLeod. Now that's where I'm at. But the root is just that /. That's the root. Top of the folder structure of the directory. One thing which is interesting are file extensions. So these little letters, you don't often see them anymore at the end of a file, but you could turn them on to show them. And that tells your computer what application should be used to open up that type of a file. And so file extensions are just arbitrary. You could create files with whatever extension you want and then just associate that extension with some piece of application software in your computer. But that's the point of the file extension, to say, hey, use this piece of software when opening it. Also good to know about is file compression. So let's say I had a bunch of images, and I do happen to have some images here because I was doing some research for stock photos. So let's say I want to send these images to a friend. Right now, each of these images, let me just copy them. Copy, copy, copy 3 items. I'll put them in a new folder, temp, drop them in there. So right now, oops, oh, I already compressed it. Get info, that was pretty fast. get info. This has 1.3 megabytes. 1.3 megabytes. Those images. And after I compress it, right-click and choose Compress that folder. That folder now has get info, 1.3 megabytes. Compressing it didn't do anything. But sometimes you compress things, saves size, and it's easier to send. Easier to send. But if you ever get a zipped file, how do you uncompress a zipped file when you get it?
You get a converter to convert it back.
Yeah, well, in Windows and Mac, you just right-click it. Like, I'm not sure. Let's see if that was one of the options there. Kind of a funny sound. So right-click it and copy, show, view, reveal. Yeah, I just double-click it on a Mac. On Windows, you have to right-click it and say extract or something like that. So other utility programs be like antivirus software or firewall. And some of those. System restore. And user accessibility. So accessibility is a cool deal. So here I have accessibility right there. And I really like this accessibility feature that use scroll gesture with modifier keys to zoom. Like, I love that. I press command and I scroll and I could zoom in on my screen. Like, that's totally awesome for me as a teacher, because I could be like, hey, look at this. Last thing I'm going to show you is a VPN. Do you all know what a VPN is?
Verified personal network, right?
Verified personal network. Virtual private network. Virtual private network. And have we talked about VPNs in here yet?
No.
No. So VPNs help protect your privacy, and they can help protect you against like evil twins. So have we talked about evil twins?
I've heard of, isn't that like using internet from something that's not what you wanted to access it from?
Yeah. And so, like, you know, Verizon has all these hotspots where if you're a Verizon customer, you could connect to them, right? Yeah. And so you might just go stand up a Wi-Fi hotspot and call it Verizon. And then people who automatically have set their phones to or computers to connect to Verizon will automatically connect to your Verizon. It's got the same name. And then when they do that, you could run software that watches all the traffic that's going through. And so as they make requests, right, you could actually see, like, what are they asking for, what images. You might even be able to see their passwords, their usernames. And so, you know, you're out and about, you're at cafes, you just connect to hotspots. It's free, you don't really think about it. But then somebody could be watching what you're doing. So what you could do is you could connect to a VPN. And a VPN is like a service you pay for. And basically, I always connect to this VPN. And the best VPN in the world is Proton Mail. Proton VPN. And so Proton VPN is made by people, engineers, and Proton Mail made by engineers at CERN, Center for European Research Nuclear, which are the same people, same organization that created the web, the World Wide Web. And so these people are awesome. And so it's $4 a month. And then whenever you go online, you connect to them. And any request you have gets encrypted at your computer. So it's totally encrypted, and it gets sent to them. And then they decrypt it, and they make that request and go get what you want from their computer, bring it back to their computer, and then re-encrypt it and send it back to you. Think about that for a second. I want to look at Facebook, my homepage. And I say, hey, show me my Facebook homepage, right? I go to that in my browser. That gets encrypted, sent to the VPN. They decrypt it, and they say, oh, you want to look at your Facebook page. They go get that page, bring it back to their computer, encrypt it, and then send it back to me. What that means is nobody can ever know what I'm looking at.
Except you.
Yeah, and the VPN. But I would rather choose the one entity organization which could potentially have access to what I'm looking at than just let it be arbitrary. And I'd rather choose an organization that specializes in privacy and security and that I give money to them and they make their money off of ensuring people's privacy and security than just like, not doing it or trusting my ISP or whatever hotspot I'm in. So even right now, and so I already had a paid service to something else, so until that expires, I'm using a different one. But even right now, I'm connected to my VPN, so everything's encrypted. It's kind of cool, right? I think it's cool. So that's just a little bit about operating systems and system software and how that all works. Anybody have questions? Just close it all down. I'm going to shut down the... What's your question? Maybe it'll be good on the video.
Is it possible to use internet without having an ISP?
Oh, I don't know. How are you going to get connected to the internet if you don't have somebody providing connection? I guess you could just stand up your own IP address. And you'd have to have like a direct cable connected. I don't know. How would you do it? That's a good question. Let's ask. Is it possible to connect to internet without ISP? Without and ISP. Internet without ISP? So it looks like it's possible. You probably have to buy a direct connection. Any other questions?